Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on basic statistics by talking about the final statistic that I want to review, which is standard deviation. So standard deviation is going to be the first measure that we have that measures variation. And so give ourselves a little bit of space here if we can. I want to be able to see our sample data set here. But standard deviation is basically the average distance any one point is going to be away from the mean. But that'll make a lot more sense when we talk about it visually. So the equation for standard deviation, in case you haven't seen it before, it's usually demarcated as STD, or sometimes you'll see it demarcated with a theta, is that it's going to be equal to the square root of x of the summation from I equals 1 to n of x sub I minus x bar over n, right? So we've seen the summation of x sub I. We've seen this before when we talked about mean. This is just the summation of every item in the data set minus x bar. This x bar is going to be the mean that we calculated earlier. So we're going to square that difference. Then we're going to sum that, and then we're going to divide that by the number of observations in the data set. Right, so this is the standard deviation. Right? It is the difference of each observation from the mean squared divided by the number of observations, and then we take the square root, just to make sure that's clear, take the square root of all of that. Okay, so rather than going through doing the entire calculation for our sample data set here, because there's a lot going on, I encourage you to pause the video and do the calculation for yourself. But if you do the math, you end up with a standard deviation of 2.79. Okay, so that's 2.79. So what this means visually is, given the mean, right, 2.79 along the number line here, so 5.2 plus 2.79 we'll say is approximately 3. So from 5.2 plus 3 to 8.2, and from 5.2 to minus 3 is going to be 2.2. Right, so approximately this distance, right? Because standard deviation is a measure of distance from the mean for how spread out the data set is. So the higher the standard deviation, the more spread out the data is. Right? The lower the standard deviation, the more concentrated the data is. Okay? So standard deviation, again, visually represents how spread out the numbers are along the number line, with higher standard deviations, meaning the data is more spread out along a number line. Lower standard deviations mean the data are closer together or more concentrated relative to the mean along this number line. Okay? So again, standard deviation is just the difference of each observation from the mean squared, added up, divided by the number of observations in the data set, square root. And the way you interpret that is relative to the mean. Higher values mean your data is more spread out. Lower values means your data is more concentrated. And when we talk about standard distance, which is essentially standard deviation for geography, right, it's going to give us a sense of how dispersed our data is versus how concentrated our data is. So hopefully this made sense. Again, if you have any questions, as always, please reach out. Thank you.